Hi people, notes 2.3 are on factoring by grouping. And the first thing that we're going to look at are something called binomial common factors. So it says, is there anything in common with the terms listed in the expression below? So if you look at the terms that we have here, this is technically one term together, this 4 times w plus 1. And then this 5y times w plus 1 is another term together. And the reason why I know that is because this plus sign is what's separating my terms. And because this is in brackets, it's 4 times something plus 5y times something. So this is all one term. This is all one term. So we've got two terms all together. So what's in common in both of my terms right here? I've got that w plus 1 is in common right here. So if you take a look, if I were to factor this w plus 1 out, that would be like my GCF, I would look and see what's left over when I factor it out. Well, don't forget that when we factor, we're essentially just dividing, right, by our GCF. So like our first term that we're looking at here, this 4 times w plus 1, I'm dividing out that w plus 1, so we have a 4 left over. So that's the first term right here. And then when I factor it out of the 5y, the w plus 1 still cancels out, so I have a 5y left over. And if you were to look at this right here, if I were to distribute the 4 through, this is what I have here. If I were to distribute the 5y through, this is what I have right here. So this is what it looks like when I factor it out. So let's take a look at some of our examples here. Our first example has an a minus 1 in common, so I can just factor out a minus 1. Well, when I factor it out of this first term right here, I have a 2y left over. And then when I factor it out of the second term right here, I have a minus 3x left over. And this is my final answer here. All right, this next one is a little bit trickier because if you look and see, this x minus y and this negative y plus x don't look like they match, but actually technically they do. So if I just copy down this x minus y right here and this minus 3b, I can rewrite this expression right here in a different order. So I can put the x first, the negative y second, and if you look and see here, now these two match with each other and I can factor out that x minus y. And when I factor it out of the first term, I have 4a left over. And when I factor it out of the second term, I have a minus 3b left over. And this has my common binomial factor factored out. Okay, but in our next example, this one is even trickier because this 2a minus b and this b minus 2a are not exactly the same. So like, for example, I could just copy down this 3c times 2a minus b. I could copy down this 5d, and I can rewrite this in a different order. So I can put the negative 2a first, and then I can put the plus b second. So it could look like this right here. They still do not match. Like this is not the same thing as this. But if you notice, if I multiply this expression by negative 1, so if I multiply negative 2a by negative 1, I get positive 2a. If I multiply b by negative 1, I get negative b. So instead, what I can do is as follows. So I'm just going to copy down this. I'm going to copy down the 5d. And then here, I can just factor out a negative 1. So when I factor out a negative 1 from negative 2a, this becomes positive 2a. When I factor it out of this b, this becomes negative b. And then 5d times negative 1 is negative 5d. And now they have something in common. They have that 2a minus b is in common. And when I factor it out of the first term, I have a 3c left over. When I factor it out of the second term, I have a minus 5d left over. Now, really quickly about this expression, this 3c times 2a minus b plus 5d times b minus 2a. I showed all of this workout so you can see step by step what it is that we need to do. But the goal is for you to eventually be able to realize that you can just factor out a negative value. So this becomes the opposite sign, and then you can just switch these two around if you factor out a negative. Okay, and then once you do that, you can take out the 2a minus b that's in common, and then you've got 3c minus 5d left over. Okay, so how to factor by grouping. Step one says to group terms that have a common factor. So I'll show you what that means in this first example that we have right here. So if you notice the AC and the BC, I'm going to group these two terms together because they have a C in common. Okay, and then I'm also going to group the AD and the BD together because these two have a D in common. And then it says to factor each group by GCF to try to find a common binomial factor. So in my first group right here, they have a C in common. So I'm going to factor out a C. When I factor it out of AC, I have an A left over. When I factor it out of BC, I have a B left over. Okay. In the second term, they have a D in common and it's positive. So I'll write plus D. And it's really important that you have a sign here. Either has to be a plus or a minus. If you do not, it is mathematically incorrect. Okay. When I factor out the D here, I have an A left over in the first term and a B left over in the second term. So it's A plus B. And then we should have added a third step right here. Which is to factor out the common binomial factor. So if you see here, there's an A plus B in common. That's the common binomial factor. When I factor it out of this first expression here, we have a C left over. When I factor it out of the second expression right here, I have a positive D left over. And this is how you would factor it. But here's the thing. Sometimes you might have to change the order around in order to find a common factor. So you may need to rearrange the order. So for example, this example is exactly like what we did here, but I just want to show you how it would work if you did it in a different order. So like, let's say instead, I'm going to group the AC together with the AD because they have an A in common. Okay, and then I'm going to group the BC together with the BD because they have a B in common. So when I do that here, in my first expression here, I can factor out an A. And when I factor out an A from AC, I have a C left over. When I factor it out from AD, I have a D left over. Here, in this example here, they have a B in common. So when I factor it out of the first term, I have a C. Second term, I have a D. Okay, this time my common binomial factor is the C plus D. So I'm going to factor out the C plus D. When I factor it out of the first term, I have this first expression here, I have an A left over. When I factor it out of this expression here, I have a B left over. And this is my answer here. Now, if you notice, these two answers are in a slightly different order. Here we've got A plus B first, here we've got A plus B second. C plus D second versus C plus D first, but they are saying the exact same thing because if, for example, I told you to tell me what 2 times 3 was, you would tell me it's 6. If I told you to tell me what 3 times 2 is, you would still tell me it's 6. So it doesn't matter what order we do this in because the commutative property says we can multiply in any order we want. So let's go ahead and apply this. So in our first example here, we want to group together terms that have things in common. So if you notice the 5m squared t and the minus 10m squared have things in common. And then I've got t squared minus 2t. Those have two things in common. They have something in common. So I do not need to rearrange anything. So in my first group right here, 5m squared and negative 10m squared have a 5 in common, and they also have an m squared in common. So when I factor that out of the first term, I have a t left over. When I factor it out of the second term, I have a negative 2 left over. Okay? In the next expression that we have here, there is a t in common with the t squared minus 2t. So I'm going to write plus t. And then when I factor it out of the first term, I've got t. And when I factor it out of the second term, I have a minus 2. Now, when you look at this, you can see, oh, there's a t minus 2 in common. And when I factor that out of my first term, I have 5m squared left over. When I factor it out of my second term, I have a t left over. And this has been factored by grouping. In this next example, be careful because if I group the xy and the 12 together and then the 4xy and the 3y together, there's nothing in common with either of these groups, which means that I want to rearrange my groups. So I've got a few options. I can either group the xy with a 4x because they have an x in common, or I could group the xy with a 3y because they have a y in common, okay? And then if I were to group xy with 4x, then that means that I would group the 12 with the 3y. And those two have something in common. They're both divisible by 3. The 12 and the 3y, I mean. Okay? If, for example, I were to stick with xy with 3y, then I would have to group the 12 and the 4x together, and they have a 4 in common, so that would work. It's totally up to you how you choose to group this, as long as you can actually group things, or you can actually find common factors. So let's go ahead and do let's do it the first way right here. So I'm going to group the xy with the 4x, and then I'm going to group the 12 with the 3y. Okay, so here in my first group, there's an x in common. When I factor it out, I've got y plus 4. In my second group, there is a 3 in common. When I factor that out, I get 4 plus y. Now, just a quick note, y plus 4 and 4 plus y are the exact same thing. They mean the exact same thing. So it does not matter. I don't even have to rearrange this, rewrite this. I can just directly say that there's a y plus 4 in common. When I factor that out of my first expression here, I've got an x left over. When I factor it out of the second one, I've got a 3 left over. And this is my final answer. Okay, so in this next example, this one's a little trickier, so pay really close attention to this one. So if you notice, the 6x squared y and the negative 12x do have something in common, but the xy and the minus 2 do not have anything in common, okay? And you can rearrange this if you want, but I actually want to factor it this way so you can see how this is going to look. As long as one of the groups has something in common, um, you it is possible to be able to factor by grouping. Doesn't always necessarily mean you can, but it is possible. So let's look at our first group and see what's in common. So 6 and negative 12 are both divisible by 6. And then x squared and x squared y and x have an x in common. So when I factor that out here, I end up getting xy, okay? And when I factor it out of the first term, because 6 divided by 6 is 1, x squared divided by x is x, and then the y just tags along. When I factor it out of the minus 12x, I get a negative 2, okay? And then here in this expression right here, there's nothing in common with these terms. So what I would do is I would factor out a positive one. And again, do not forget to put this plus sign, and I forgot to stress it here. Do not forget to put that sign there. When I factor out the 1 here, I get xy minus 2, right? Nothing's changed. But by doing that, I can see, oh, there's an xy minus 2 in common. When I factor that out from my first term, I have a 6x left over. From my second term, I have a 1 left over. And now I've factored this expression. And that's it for this video. Let me know if you have any questions. Otherwise, I'll see you in class. Bye.